आज ही डाउटनट ऐप डाउनलोड करें। डाउटनट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
इस क्वेश्चन में हमें गिवन पीवी साइकिल को, ये जो कंप्लीट साइकिल है जो कि क्लॉकवाइज है, इस गिवन पीवी डायग्राम से हमें इन चारों क्वेश्चन को आंसर करना है। तो पहला क्वेश्चन है द वर्क डन बाय द गैस। जो ये कंप्लीट साइक्लिक प्रोसेस है, इसमें नेट वर्क डन कितनी हो रही है। सेकेंड पार्ट कहता है द हीट रिजेक्टेड बाय द गैस इन द पाथ सी टू ए एंड द हीट एब्जॉर्ब बाय द गैस इन द पाथ ए टू बी, ये कैलकुलेट करनी है। थर्ड पार्ट है द नेट हीट एब्जॉर्ब बाय द गैस in the path P to C, and the fourth part is the maximum temperature attained by the gas during this whole cycle. So we'll start from part A. So the net work done by the gas is equals to the individual processes, because ये complete cycle 3 different steps से मिलके बना है, तो हम तीनों step का different work done निकालेंगे और उसे sum करेंगे to get the net work done. So work done during the path AB plus work done during the path PC plus work done during the path CA. So अगर आप path A to B देखेंगे तो it's an isochoric process and the work done during the isochoric process is 0. And work done from B to C. So clearly हमें मालूम है in a given PV diagram, work done from B to C can be calculated as the area under the B to C curve. So that is area under this shaded region that I'm shading with the red pen. So clearly it's a trapezium, and since it's an expansion process, that is work done by the system in which the volume has increased, therefore it's considered as negative by the convention of chemistry. So half into area of trapezium is half into sum of the parallel side, that is 3 P naught plus P naught. That is sum of the parallel sides into distance between them, that is V naught. So this is the whole magnitude with sign of the work done in the process B to C, and the work done from C to A, as you can clearly see, it's a compression, that is work done on the system in which the volume has been decreased, and the work done from C to A is the area that I'm shading with this black pen. It's clearly in a square with length P naught and breadth V naught. So the work done in the path C to A is positive P naught V naught. So on further simplification, you will get net work done as minus P naught V naught. So that is the answer for the path A. Now coming to the part B of the question. The heat rejected by the gas in the path CA. If you see the path C to A, it's clearly a compression. So if you calculate QCA, and since it's a compression, QCA is delta U minus W. This is via first law of thermodynamics. So delta U is NCV delta T minus work done. And if you clearly see the temperature, the change in temperature here is the temperature at A is T1 and temperature at C is T2. So the difference is T1 minus T2. And according to question, it's given 1 mole of a monoatomic gas. So N is 1, and for monoatomic gas CV is 3 by 2 R, and temperature is T1 minus T2, and work done from C to A that we have calculated here is P naught V naught minus P naught V naught. So 3 by 2 RT1 minus RT2 minus P naught V naught, and RT1 can be written as P1 V1 by 1, that is mole is 1, minus P2 V2 minus P0 V0. And if you clearly see at temperature T1, pressure is P0 and volume is V0. So we can write this as 3 by 2 P0 V0 minus, at 2 the pressure is P0 and volume is V0. That is P0 twice of V0 minus P0 V0. So on further simplification, you will get minus 3 by 2 P0 V0 minus P0 V0, that is minus 5 by 2 P0 V0. So the net heat rejected by the system, that is heat given by the system, that is considered as negative. So QCA, it's completely 5 by 2 P0 V0. And the second part of the B question, the heat absorbed by the gas in the path AB. If you see the path A to B, it's clearly an isochoric path in which work done would be 0. If you see QAB, that would be equal to delta U, because work done is 0, because it's an isochoric process. And delta U is an CV, change in temperature. And as we move from A to B, temperature varies from T1 to T2. So N is 1, CV is 3 by 2R for a monoatomic ideal gas, and delta T is T1 minus T2. And if you see at temperature T1, here the pressure is P0, volume is V0. So 3 by 2 RT1 minus RT2. So 3 by 2 RT1 can be written as P0 V0 by moles, that is 1, and RT2 can be written as, at temperature T2 the pressure is 3 P0 and volume is V0. So RT2 can be written as 3 P0 V0. So on further simplification, you will have minus 3 P0 V0. So the heat absorbed by the gas in the path AB, that is QAB, is minus 3 P0 V0. So this is the answer for the part B of the question. The heat rejected in the process C2A is minus 5 by 2 P0 V0, and the heat rejected and the heat absorbed in the path A to B is minus 3 P0 V0. Coming to the third part, the net heat absorbed by the gas in the path B to C. If we see the path B to C, it's clearly an isothermal in nature, because the temperature at B is also T0 and the temperature C is also T0. So in that case, in the C part, QBC would be equal to minus of work done, because delta U is 0 since it's an isothermal condition. And clearly when you move from B to C, the area under the curve will give you the work done, and we have already calculated the work done in path PC here, that is minus 2 P0 V0. So if you put that here, minus minus becomes positive. QBC is 2 P0 V0. Now moving to the last part of the question, that is the maximum temperature attained by the gas during the cycle. So firstly we need to find the relation between the given temperatures in this graph, that is T1 and T2. We need to find the relation between the temperature, and whoever is greater, either T1 or T2, will be the maximum temperature attained by the gas during the cycle. So if you see the path AB, it's an isocodic path because it is happening at the constant volume. So if you see in the path A to B, if you see in path A to B, if you clearly see, it's an isocodic process. So we can write in the option D, path AB is isochoric. Therefore, volume at A must be equal to volume at B, and volume at A can be written as nRTA by PA is equals to nRTB by PB. And if you see, the temperature at A is T1 and pressure is P0, and temperature at B is T2 and pressure is 3 P0. So putting that in this equation, we'll have N gets cancelled on both sides, R also gets cancelled. So TA is T1, PA is P0, TB is T0, PB is 3 P0. So T2 is 3 times T1, and T1 can be written as P0 V0 by R. So the maximum temperature attained in the cycle is T equals T2, and that is indeed 3 P0 V0 by R. So this is the complete solution of this question and all four parts.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।